would like to maybe kind of lead into talking about launching into space now, because this is a powerful idea. The fact that we're able to launch out of our Earth's atmosphere. And I was going to talk about the STS-116.
Mm-hmm.
This was a 7-member crew that you were on, and you were on a 12-day mission. So let's journey back to the year of 2006. And on a 12-day mission, it kind of feels like that's almost the extent of like a vacation, or but so first of all, like, what does it feel like to sit on top of a massive rocket?
Well, most people ask, is it scary? And the answer is no. You're too busy thinking about your tasks to be very worried about the space flight. But it is, how do I describe it? Perhaps intimidating. It's a very serious day. You know you're about to get onto a rocket that intellectually you know is potentially a dangerous thing. The space shuttle, didn't have an accident-free program. But mostly astronauts get on board thinking about what they need to do, because there are thousands of things an astronaut is going to do in that 12-day mission, and hundreds of them happen during launch and ascent and immediately after you get to space. And the world is watching. Your crewmates are relying on you to do everything that's on your plate accurately. So astronauts generally are strapping in, thinking about their tasks.
So you're literally, your mind is so overwhelmed with all these tasks lined up that it's just worrying is something you have to kind of compartmentalize, probably.
Well, there's just no time for it. Yeah. It's easy to compartmentalize the worrying because there's just no time for it. We are totally preoccupied with the task at hand, which is getting into the space shuttle safely, strapping in, configuring all the switches, launching, and being ready at a moment's notice to execute one of many off nominal or contingency procedures to help get us home, potentially in only minutes if something went wrong. So you're just completely preoccupied with those thoughts.
That's fair. Yeah, I mean it's dangerous. There's 100 things that have to go right, more than 100 things that have to go right when you actually launch, land, or anything else in space flight. So being concerned with your tasks is going to occupy a great deal more of your attention. But so I guess I have to ask, just kind of also leading into the topic of the day, where the SLS is taking a while to get up into space. Were there any kind of scrubs or any kind of delays or worries about just the initial?
Yep. Both of my flights we scrubbed and had to launch a day or two later. And
do you recall what happened?
Part of the space launch business. For a rocket to launch, forget what the crew has to do. 1 million things have to go almost perfectly. Well, there are some margins, but 1 million things have to go almost perfectly for the vehicle to be ready to roll out, to be fueled, to be checked out. And ready to go, ready to launch. And if any of those things don't happen, generally speaking, you scrub the launch. So I would say, for all the launches I've been involved in, the success rate's actually very impressive. If you think that any one of 1 million things could stop you from launching on any particular day.
The fact that you're still here actually is a success story in itself, because, I'm old enough to remember when the Challenger thing happened, and that was harsh. That was terrible,
and people learned valuable lessons from Challenger, and then again, sadly, we had to learn lessons from Columbia, and I think I see real evidence of those lessons being applied to all the launches that came after them. We became more cautious about the things that mattered, and I think that's at least a good outcome from those tragedies.
I am seeing that, especially with the fact that NASA is more willing to scrub more and just kind of take a step back and really look at the problem and make sure they're doing it right, which to me that matters, because it's not just billions of dollars of infrastructure. These are human lives and the people that they touch and their families, their children. It's just, God,
Yeah. Well, and not only are we better at decision making, I think, and setting expectations about the likelihood of a scrub, but the newer vehicles actually have something in common with the very first vehicles. It's easier to rescue the crew from a bad situation. And to explain what I mean by that, I have a little prop here. This is my model of the space shuttle. And as you can see, the crew compartment in the space shuttle, this is the piece where the crew live, 7 people in that small area, is attached to what carries the payload bay.
Okay.
And if something goes wrong with the shuttle or the rocket stack that it's sitting on, if something went wrong, you couldn't separate just the crew module and bring the crew back safely. You had to do something with the entire shuttle, which was often possible, but very difficult. Today's rockets, I think, all have something interesting in common. They have escape systems. These are either pusher or tractor rockets that help pull the capsule off the booster when something goes wrong. And those systems allow you to get the crew away, just the crew, which is really the only thing that's not replaceable here, just the crew away from the rocket very, very quickly. And the more quickly you can do it, the wider a range of problems you can deal with safely.
Is this similar to the Blue Origin escape system that they have on their New Shepard?
Yes, it is. And all manufacturers now are putting escape systems into their vehicles and keeping the crew compartment as small as they can. And actually, if you look back, it's the same capability that Mercury, Gemini, and Apollo had back in the 50s and 60s. So, as they say, there's nothing new under the sun. Well, escape systems aren't that new, but the shuttle didn't have one. It had a limited capability for astronauts to blow a hatch and then parachute out. But that only worked within a certain range of speeds and altitudes.
Yeah. If you're really high up and there's probability you're going to burn up in the atmosphere. And
if you're high up, you're going very quickly, and your spacesuit's not designed to dissipate energy in a ball of plasma. If you're very low down, there isn't time to get out. So there's a window between those two things where that system of jumping out of a hatch with a parachute works. Thank goodness we never tested it.
Yeah, it's always good to have them. It's better to have it, not need it, than to need it and not have it.
Yeah, I should correct myself. We did test it long before I joined NASA, but we never had to use it in anger, and I'm grateful for that.
Me too. And I'm glad things are getting better for NASA and their projects, even though SLS has been delayed. It's fine. They know what they're doing. It's
so much more important to get it right though than to do it quickly.
Oh yeah, for sure.